In the shadowed labs of Murray Hill, New Jersey, where the hum of fluorescent lights mingled with the scratch of pencils on paper, a quiet revolution was brewing. It was late 1947, and the world still relied on the bulky, fragile vacuum tubes that powered radios and early computers, devices as temperamental as they were enormous. But on this fateful path, three brilliant minds at Bell Labs were about to shatter that world with something unimaginably small. Imagine a device no bigger than your thumbnail, capable of amplifying signals with the precision of magic. This is the story of the transistor's birth, a tale of persistence, serendipity, and the spark that ignited the electronic age. It began in earnest on November 17, 1947. John Bardeen and Walter Brattain, two physicists driven by an unyielding curiosity, set to work in the solid-state physics group. Their mission was audacious: to create a solid-state semiconductor that could replace those unreliable vacuum tubes. They dreamed of a field-effect transistor, a device where voltages applied to a germanium crystal would modulate its conductivity, like a valve controlling water flow. Day after day, they labored over slices of germanium, etching circuits and probing with voltages. But the material fought back. Surface states, those pesky invisible barriers of dangling bonds and impurities, blocked their efforts. Copper compounds formed unwanted layers, turning promise into frustration. Weeks blurred into a haze of failed experiments, each one a reminder that the path to genius is paved with dead ends. Then, on December 23, 1947, as winter's chill seeped through the lab windows, breakthrough struck like lightning in a bottle. Bardeen and Brattain, undeterred, shifted their approach. They pressed to gold foil point contacts, mere thousandths of an inch apart, onto a sliver of germanium, just a triangle's edge slicing through the crystal. A third contact served as the base. With bated breath, they fed in a tiny electrical signal, and there it was, the transistor effect. The output power surged greater than the input, amplifying the signal with crystal-clear fidelity. Cheers echoed faintly in the room. This was no mere amplification, but a bipolar marvel where minority carriers injected life into the flow. The point-contact transistor had been born, a fragile beast of gold whiskers and germanium heart, proving that semiconductors could indeed control and boost electrical currents. Word spread quickly within the labs. William Shockley, the group's towering leader with a mind like a steel trap, seized the moment. He dove into the theory, unraveling the why behind the success. The term transistor, coined by engineer John R. Pierce as a portmanteau of transresistance, stuck like glue. But Shockley wasn't content with this delicate prototype, prone to mechanical whims and low power. Over the winter of 1947 into early 1948, he wrestled with the failures of their initial field effect dreams. Surface states had been the villain, he deduced, those atomic gremlins trapping electrons at the crystal's edge. Drawing from ancient patents by Julius Edgar Lilienfeld in the 1920s, Shockley pivoted. He envisioned a sturdier design, a layered sandwich of semiconductors, p-type and n-type materials fused into junctions. By June 26, 1948, Shockley's vision crystallized into the bipolar junction transistor. Patent 2,569,347 captured a robust n-p-in structure where emitter, base, and collector formed stable barriers without fragile wires. No more pointy gold foils. Diffusion created the magic. Meanwhile, across the Atlantic in Paris, Herbert Materi and Heinrich Welker stumbled upon a similar point-contact wonder in June 1948, dubbing it the transistron for France's phone lines. Their August 13th patent echoed Bell's December triumph, a parallel echo in the halls of discovery. Yet Bell Labs held the lead, their device the first to breathe. The true leap came on April 12, 1950. Chemists Gordon Teal and Morgan Sparks, masters of crystal alchemy, grew a high-purity germanium ingot using the zone-melting technique, a slow, molten purification that banished impurities like fog before dawn. From this flawless crystal, they sliced and doped precise n-p-in layers, birthing the first working-grown junction transistor. Stable, scalable, it amplified signals with the reliability of clockwork, shedding the point contact's frailty. On July 4, 1951, the world learned of this sandwich. Marvel through Bell Labs' press release, a device smaller, cooler, and hungrier for power than any tube. From those Murray Hill nights, Bardeen, Brattain, and Shockley forged not just a gadget, but the seed of tomorrow's machines. In 1956, their genius earned the Nobel Prize in Physics, honoring the transistor effect that tamed the semiconductor wilds. And so, from a humble germanium sliver under golden points, the transistor emerged, a whisper of electricity that would roar through history. Subscribe for the daily feature videos.